So to help us successfully execute or like just do the training process, we need environments, and we have multiple options for the data science process that we would perform in data manipulation that we would need to do the machine learning process. And we have multiple environments, and then I will go through these environments briefly, and then just we will go directly to the topics that we have for today. So the first one is using your own local environment. To use your own local or to create your own local Python environment, you would have to install Anaconda with Jupyter and all the required packages that you would need for executing any kind of code that you might need for either processing data or training a machine learning model or whatever execution that you might need. So that's one option. And the other option is using Anaconda's cloud environment. Anaconda not only just provide you multiple versions of either the full packaged Anaconda or the minimized version of Anaconda, but it also provides you a cloud account that you can use with minimal setting or configuration, and then just you can do your machine learning or data processing on the cloud environment of Anaconda. And yeah, the third option we have is using Google Colab's cloud environment, and for which you'd need a Google account, and you know, set up your the Google Collaboratory on your OneDrive in Google. And the other one is Microsoft's Codespace, which comes with GitHub. As you know, GitHub is owned by Microsoft for the last couple of years. Microsoft owned it, and Microsoft is providing a Codespace cloud environment so that you can do machine learning, and this has got a certain limited time that you could use. As far as I know, Google Colab environment, I haven't seen any limit, so you can use Google Colab, but Codespace has a certain limitation, and the size of the virtual machines that you would get from Codespace is not, based on my observation, are not as you know, big as the VMs that you would get from the Google Colab environment. In any case, we can quickly see so just let's quickly go through the links and so Anaconda can be found here. Yeah, so you can choose if you can use a free download of Anaconda, and you basically just get an environment and okay, so you get you can download Anaconda and then just install it on your machine, and you will get like just different tools. One of the tools that you would use is Jupyter, and the other is SciPy, Spider. All these are applications that you would you can use to do any kind of data analytics or machine learning process. And just my favorites are Jupyter and TensorFlow. TensorFlow is mainly for it's just a Google own platform that you could utilize, and also library that you could use for deep learning. And Jupyter is just a web-based tool that you can add sales, write code, and execute to perform whatever executions that you would need on your data. And the second one that we have is the Anaconda. At least I hope you took some time to go through this, and I just, or you might already have this set up for yourself, but there are steps, and from Harvard University's website, there are steps that you could follow to set up Anaconda Python installation and Jupyter Notebook setup. So these are the things. Some of the details that are shared here are school specific, but the others most of them are general that you could use for setting up the environment. And the other is the Anaconda cloud environment. This we can see you can have a Jupyter notebook created for you in the Anaconda's cloud environment, and we can see here and getting started, and you can sign in, you can register here, and then you can have your own Anaconda hosted cloud environment, Anaconda hosted cloud environment. So let me see. I did register recently. Yes, I have this and signing in, and then I will get directly to my server, Anaconda hosted server, and I can basically start coding. Just let it load. While it is loading, I will go to the other link. And so Anaconda Nucleus is just a free cloud environment. Are those questions? If you don't have questions, please lower your hand. And if you have questions, I will give you a chance at the end. Maybe I asked you folks to show me thumbs up earlier. If do you have any question, please write it down on the chat. If you don't have questions, just lower your hand. You just wherever you clicked the raise hand, click that back, and it will lower your hands. Okay, the Google Colab. It looks like everybody is raising your hand. Don't click raise unless you see a hand on your image. Clicking does raise it. If you have any question, please write it down. Perfect. Yeah, I think just only 2 people are remaining. I can live with that. Yeah, please don't touch raise hand unless you have a question. raise hand የሚለውን አትንኩት። raise hand የሚለውን ከነካችሁት it distracts me. I assume that just you might have questions, and if you have, please write your questions on any question. Can you hear me? Oh, okay. I see. Thank you. I think the Anaconda is not visible. Yeah, I will restart my sharing. I have to share the screen. I will stop sharing and start sharing again. Thank you. And I will share again. I will share my entire screen. Give me a moment. Okay, let's see. Okay, I hope you see now my share. Okay. Okay. So let me know. Yes, the Anaconda browser wasn't being shown, and now, so the free download Anaconda, it is www.anaconda.com, and download. It will give you this free download, and you will find the link from the email that I sent last week. Last week I sent this email with a table, and this table shows you the different options that you have to execute code, and just for for our machine learning execution, we will use any of these environments. For offline execution, I suggest you set up your own local environment. Your local environment enables you to download Jupyter notebooks that I will be sharing over the next several weeks, and then you can execute them locally. And just today, I will have lots of notebooks that you can take, especially just related to the Python data science handbook, and then just you can execute that online, and or you can choose any of the other environments. So I explained that you can download the Anaconda library and Anaconda application and the corresponding Python details from here. To do that, the first link takes you to this page, this download page. This download page gives you, and you can start, you can download or start coding now. Start coding now takes you to the cloud environment. But if you want, the cloud environment requires you to have constant internet connection. And if you are trying to do things at home and don't have, a good internet connection, then just you would have to you would have to download the Anaconda application and install everything that comes with it. And the Anaconda application comes with multiple tools that you can enable. And then just the steps that the second link from the email brings. So this second link from the first row in this email brings you here. So here like just in the Harvard University's wiki, you will find steps. I didn't want to recreate everything that has already been created by such a great school, so you can utilize the Harvard University's instruction to set up your environment. And then just they added some brief explanation about what Jupyter notebook is and anything. And then you can choose whatever way. And this is the first approach, just to install Anaconda on your local environment, set it up, and use for execution. The second option is using Anacondas. Like the second option is right here. The first one is downloading locally, installing Anaconda, and setting it up and using it for your code executions. The second option is also here, start coding now, which takes you to the cloud environment. And this cloud environment, as I told you, now I logged in as Danny Aberra here, and then just I can write, execute notebooks. And then just is launching the server. Now, this is a virtual machine dedicated for me for this session, and is starting a server. So this server is accessed, and I can start writing code. And I will quickly show you. As you can see, it says Jupyter Lab, and now the environment is quite ready. The best thing, so this was my server. I wrote this code last time, 7 days ago, and then it came back for me. Obviously, the server basically grabs where the file is stored from, but the server could be used for multiple other people. It could be a shared server, but the file is saved on a cloud location from where this server loads it and brings what I did in the past, what I stored in the past. So as you can see, now this is my first, usually like just the first programming language that you do is Hello World. Hello all from Ethiopia. Then just execute. There you go. Now just we did nothing, zero setup. We did zero setup. The only thing that we did is we created a cloud account on Anaconda, just using this start coding. And then if you click start coding, code in the, and then just it comes here. Create a free Anaconda account, and then just you can provide your email and password, and then you confirm your password. Maybe like just you would get an email to your email address to confirm. Let's try this with a different email that I have. Yeah, so just do it for yourself for the interest of time, and then you can get a cloud environment just like the one that I have here. And here, let's say 1 to 2. Let me make it just 1 to 2, and then just it will write only 2. So this is basically greeting, trying to print this 100 times, not 100 times. If you want, if you change this index to 101, then 101. So this is a loop. It basically prints 100 times, starting from 1 to 100 times, because 101 is not included. In any case, so this is the cloud environment from Anaconda. in addition to what you could set up. And the advantage of setting up a cloud environment, most of them would set up the environment for you. And like just the most common libraries are installed for you. For example, like how many pip list? And see, you see, so these are the packages that are installed on this server. These many packages are already installed for you. You don't have to install all these packages, and most of these packages are very popular packages that are available for you to do the most common data analytics and machine learning processes on this server. As you can see, like just many of the things are here, and these are like just Python packages that you would need. Some of them that you would need to install explicitly if you are to set up the local environment. In your local environment, you will be responsible to install all the required packages as you run into issues, right? So this is the advantage that you would get from. And pip means Python installation platform, and then list is a list of packages. Package installation platform, and then the list. Then just it will give you the list of packages that are already available, the package and the version. And if any of the versions that you are looking for is not there, you would have to install the package and yeah, you would have to install the package. But like the cloud libraries commonly will have all that setup for you. Now, this is about the Python cloud environment. The next environment is now the Python, the Anaconda cloud environment. The Anaconda cloud environment is Anaconda Nucleus. The next environment is Google Colab. So just let's go to Google Colab and show you what it provides. Based on my observation, the Google Colab is very powerful, and you are lucky to start learning or like coding or learning data analytics and just doing machine learning using Google Colab, nowadays, because in Google Colab, like just companies are competing to offer their free environment so that you can utilize their environment with an intent that one, you learn the skills, and second, you will utilize them just in a paid subscription. Most of them don't give you free. For example, Google Colab doesn't give you everything for free. If you wanna maintain a state, you would have to pay for it. And the others as well. And in a production environment, you might need, like for learning, it's great, but for continuous execution, it's not sustainable, because the moment if you want the server to run exclusively for you in a dedicated manner, you would have to pay for it. For learning, you can use it, because for learning, you might use for an hour or two per day, or just a little, for a certain number of hours per day, that's okay. But after that, you cannot use it for 24 hours. Now, so this is the Google Colab environment, and now my account, since I already have an account set up, this account, Google Colab automatically loaded for me with my account. But if you created a Google, if you need a Google Colab environment, as I said in the email, you have to set up. You have to have a Google account. You have to have a Google account, and then just in that Google account, you would need to set up the collaborator. It's not that difficult. Just a 2-step or 3-step process from your Google account, your Google accounts, Google Drive, then just you can go from there. Here, I have this Gmail account, and in this Gmail account, I can, and so automatically it opens like just in this path. But when you start executing, it will tell you. For example, now I want to execute this line, right? So this is a code, and this code gets executed. Or let's say I wanted to add a new line here. Print hello all in Ethiopia. So I am just to execute the code. You have multiple options. So this is like just a notebook, and it's trying to look what happened. So I have this server set up for me with these details. So you see, I have 12.7 GB RAM and then 107 GB disk. So the hard drive is this big, 107 gigabyte, and the RAM of the machine is this much. So this is basically just provided for me for free. As long as you have an internet connection, Google Collaborator can be used for your execution. So these are among the free services that you could offer, that you could use for your data analytics and machine learning, data science purpose when teaching your students. The only thing that you'd need is internet connection. As long as you have internet connection, and then just your students have Google accounts, then they can utilize Google Collaborator. I used it for my students in Ethiopia at Jimma University, and it was like just successful, and we have used it with no issue. It avoids setting time, like just setup time. As I showed you earlier, now just it printed hello all in Ethiopia. It took some time because it needs to start the machine. So just connected to a hosted machine or whatever. But you can manage sessions, and you can find out like just what you could do with your machine. And to check again, as we did earlier, to check the packages that are available on this server, you can do pip list and then run. Then just you would see the list of Python packages with their corresponding version, as we did in the Anaconda environment. So all these packages are installed for you. These packages are available and are installed for you. And just as you can see, since this is a Google dedicated server, Google specific packages are installed, because the purpose of the server is for Google customers to utilize this server with other Google services and then test their code without investing money for free. And then just when they decide to use the actual production environment, they will start paying. Okay, so this is the third environment. The first is your local environment. The second is the Anaconda cloud environment. And the third is Google Collaborator. And now the fourth one is which we found out very recently. I used it in a presentation at Microsoft. And then just it was exciting for most people to see this service. And this is Microsoft's own server. And I will show you here. here. Microsoft provided service and just GitHub, Codespace, and then I have a paid subscription here. I have an account that I pay for this, and just these are the Codespace, and I can create a new Codespace or like the Codespaces that I can see on my account. I deleted everything because it counts hours, and then just like the Codespace has got a certain limits, and then just it counts hours, and it disables your account until your next month's quota. On a monthly basis, you will have quota, and until you get your next month's quota, it will disable you. Now, let's create a new space. Now, for creating a new space, you would have to select a repository, right? And then just I'm selecting a repository. The purpose of this server is to test your code. As you know, GitHub is a Microsoft code repository service that's available for with a subscription. You can start with as low as $4 a month. As low as $4 a month, and then just you can utilize it. So I'm choosing one repository that already existed in the main branch, and then look at the number of RAM that you could allocate, and you can have a 2-core with 4 GB RAM and 32 GB disk, or 4-core with 8 GB RAM and 32 GB, or 8-core with 16 GB RAM and 64 GB. And some of these are not going to be visible for you if you don't pay, because my subscription, my account has got a paid subscription. It shows me like these two. I don't think in a unpaid subscription you would get these two, but as you pay more, you can request for more. But 16-core with 32 GB RAM is good enough for most of like just the execution. Now let me start with this 2-core just for the time being, and then I will show you what happens. Now it is setting up my Codespace and starting up, and it is loading the code and automatically. So this symbol is Microsoft Visual Studio Code symbol, which I will quickly show you locally. And everything that you see, what's happening now is the code is getting copied over to the server, and the VS Code, Microsoft VS Code. I hope you all know Microsoft VS Code. Microsoft VS Code is this product. So this is a product that you can install locally and that you can use locally. So this product, Microsoft, this integrated development environment, this IDE that Microsoft offers for free, like this is a reduced version of the Microsoft's paid product, Visual Studio. Visual Studio is just an integrated development environment that has got so much more features, but Microsoft offers this Visual Studio Code. The other one is Visual Studio. This one is Visual Studio Code or VS Code. So if you see in the help about, so it tells you Visual Studio Code. Visual Studio Code. The other one has got Visual Studio Community Edition, Visual Studio Premium Edition, all kinds of editions that can be used by enterprise customers, right? So if you have more developers, you would use integrated environment and Visual Studio. But this one is freely available. You can install it from local, like just you can install it, you can download it, install it locally. Now, so this same product that you see here is hosted on the browser. So the browser has got everything. You see, like everything that you see here is what I showed you here. You see, like the icons, but this has got more icons, more capabilities. The reason why we have more capabilities here is because this is a desktop installed application. On the browser, you wouldn't enable everything that you want, but this enables you to do much more work and from your desktop. So your desktop has got more the desktop base code version has got much more capability than or features than the browser hosted. So the browser hosted has got enough. This is an extension. We will go through, we will get there, but so you can browse to the code and then just open one notebook, for example, distribution or whatever here. So this is a code. And then the moment you start loading, and then just you can choose a kernel. So install suggested extension Python plus Jupyter, and it does that. You can install Python extension from Microsoft Python language, and then just it does that. You will have this is installing, so it's setting up your environment, right? So it's setting up your environment. Now you can start executing. So the Python is installed, and now let's select the kernel. Python should come, and then just a Jupyter kernel, let's say. Okay, sorry. The Python environment, and then just this is 3.10, the latest Python. And now we have Python loaded. The Python 3.10 is loaded. No, most of the time you would see like until we get used to it, 3.9.x. So here again, let me write print hello all in Ethiopia. And then just to execute this code, I either click this, run, here it is, or I can do right while I'm here, shift plus enter will execute the code, and then you would see the result. So hello all in Ethiopia earlier, and then just from USA, my latest. So this is, so now we covered like about environments. I leave the details of setting up your environment for you. You can make a choice. You can make a choice of using either a cloud environment, or a local environment. If you choose to set up a cloud environment, just to summarize in this email has got everything. The Codespace is from GitHub, and you need a GitHub account, and a branch. And second, the other one is a Google account for using Google Colab. And the other option is you can use the cloud, the Anaconda cloud. So these three are cloud-based services, and all of them are just have a common requirement, which is getting connected to internet all the time, just all the time that you're using these cloud services. But the local environment gives you a flexibility of, just working on your code offline. without internet connection, but it requires you to install all the required package. So you would have to do that by yourself. As I showed you in the Anaconda cloud environment, in the Google Cloud, the Google Collaborator, they provide you with packages. And just let's do the same for the, give me one moment. Yeah, so just let's check what this environment has, what kind of package it has. Just percent, pip, list. Okay, I will tell you one thing. The reason why I am using percent is because I am executing this code from within a browser. But if you are running this from a command prompt, you don't need the percent. The percent is not needed. So this is the Python installed package list. As just you saw in the other, this is not. So since a new release, oh, fine, it's fine. So there are more lists here that, okay, there are packages that are not being loaded fully. Well, the reason is the setting is limiting. If we want to adjust the sale output, we have to go here and make updates to the output. So let's say 300, and then so text line limit was 30, and then just I did. Okay. Let's see if this is done. It's loading. Well, it didn't take effect, but so just for the output. Okay. Okay. Okay, that's fine. And let's see if we can rerun and see. Yeah, it's taking. Okay. Yeah, but it didn't load much, but it's because of the setting limiting. And in a text editor, it opens. Yeah, so this is how many packages there are. And as you can see, there are, as we observed in the Google Colab, we don't have much package specific to Google because this is Microsoft server. Microsoft wants you to use for Microsoft purpose. So Google related packages are not installed here. So this is just, I think you got what I wanted to say here. Any questions before I move on to the next topic? Any questions? Tafari Gabru, do you have any question? Your hand has been raised. ጥያቄ አለህ? Okay, there was a question. There were questions. Which. Yeah, okay. So let me address those questions and we'll go from there. Python 3.7 version is not available. It is available, but it's not the latest one. I think the latest one now is 3.10. Even 3.12 is there. Sorry, 3.11 is there. But 3.7 has been, I believe, like just more than a year or two now. So it's better to update unless and otherwise you have a specific requirement for keeping the old 3.7 version. You would have to use a little bit zoom the slide. I'm sorry. I am sorry. I couldn't see your chat while presenting, so I'm sorry. But maybe probably it is. I'm sorry, I was having some network issue. Okay. 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 So let me answer some of your questions. I was explaining here, and little bit zoom. Fine. I did that. Unfortunately, it's not showing the refreshed environment. And here, Python exists. Is it obsolete? I think just you would have to check the latest version in Python. But I know that we have 3.10 and I believe 3.11, but not obsolete. It is new. Uh, and could we join the local environment with the cloud at a later stage? Yes, the mainly like just the cloud environment is usually available for you to execute your code locally, your code on a cloud hosted server. But the same code can be hosted to the cloud environment. You can download it, especially just in GitHub. GitHub provides you that capability. GitHub gives you the option of tasting your code on the cloud, which you already implemented in on locally, but you have to use uh, source control mechanism. You have to connect. You have to connect your local environment not directly to the cloud hosted server, but to your GitHub repository. Then just you check in your code to the GitHub repository, and from GitHub repository you can execute your code on the cloud hosted environment. But the purpose is kind of different. The purpose is not just to let you use both your local environment and your cloud environment. If you can use your local environment effectively for the training purpose, it is fine. But for production purpose, you won't even use your local environment. Your local, maybe it could be a desktop or a laptop. You won't be using your machine for production purpose. So the cloud environment is for that purpose. And part of the reason that you are given with a cloud hosted server is to show you how your production environment could be set up just the way it is as hosted in the cloud hosted servers. Any other, which one, local or cloud, would you recommend us? I think I said earlier, the cloud environment gives you like just quick run automatically, just to learn things, not to set up, to bypass the requirement of identifying and setting all the required packages. You can use a cloud environment. But your local environment gives you another rich experience of setting up a server. Like you understand the package, what packages are required, which package, and identify the dependencies of your code on a certain package. So just the cloud, the local environments gives you that deeper level of understanding about just your code and its dependencies and the corresponding package. And after training our model on Google Colab, how can we get the trained model to use it on our local machine? Yeah, that's a very good question. You can download models are files. Okay, you can download your model and export it to your local environment and then just use it. Wherever you train your model at the end of the day is a file or a package. And then that file can be ported to wherever, or you can move it, you can download it and then just upload it to somewhere else, or locally use the model. And it depends on your PC performance and internet. Perfect. That's a good answer. The cloud, the use of cloud environment, and question. When we use Google Colab, what about the security of our codes and models? Does it protect or not? Well, it is protected for you, right? It is like most of the, I think just whatever cloud environment that you're using is protected, and the level of protection is as strong as the way you set up the account that you're using. It is accessible only by your account. I don't think any of these big companies try to tamper with personal data. So just it's strictly forbidden by law. Sorry, probably some people might have been left. Yeah. Okay. More questions to answer. Could we import and export code worked in Google Colab? Yes, definitely. You can import, export anything that you have done in these cloud environments. And what else? How can we be quite sure as code is not accessed by other person when we write the code on Colab, Codespace, and other online platforms due to the database is not on our hand? Is there any mechanism to assign either password or other security mechanism? Yes, just the way you secure your code is now. One quick question for this: you trust Google, right, with your emails, with when you communicate with people, with your friends, exactly the same way as you trust Google because you have a Gmail account or a Gmail email account and then password. You have to trust Google exactly the same way, because without having such an email account, you cannot use the Google Colab. So it is protected, it is saved for you. So that's how much trust that you can put on any of the cloud environments. Your code is protected by your account, by your username and password. If you share your username and password, it's your issue, not the cloud service provider's issue. So that's how we could say. And could we import, export? I answered that. Is it possible to integrate the platform with MATLAB? Unfortunately, I haven't used MATLAB, so I cannot say either this or that. But there should be a way to integrate. If MATLAB is good enough to integrate with development environments, there should be a way to integrate for sure. But I haven't used. I cannot say yes or no, but just you may have to check. Is there any functional difference between Python and R programming, and which one would you recommend? Well, so the programming now, this is a question of programming language. R is perfect base programming language for statisticians, and it has got so many packages. The R programming language has got so many packages that are meant for statisticians and statistical data analytics. Python, on the other hand, is so well suited for machine learning. It doesn't mean that you cannot use R for machine learning. I am currently teaching a data analytics course using R. academic environments like just use R for teaching even machine learning. For data analytics, R has got a very good integrated development environment called R Studio. You can use that. And what I like about R is since the developers of the package are researchers, the way things are documented in R for R package are so interesting and basically just well documented package. Most of the R packages that I use are well documented from documentation perspective. I'm not saying that just Python packages are not documented, but like the level of documentation is a little different from between R package and Python package. But just in short, for statistical data analytics, R is a perfect platform or programming language. But for machine learning, Python is a perfect and easy to learn programming language for machine learning, and has got so many machine learning specific libraries written, dedicated libraries written for R, for Python and Python-based integrated development environments. And more questions? Okay, I think I'm almost. When I train the model using Jupyter, Anaconda, or local machine, it says kernel died. So can I fix this problem? Probably like just, I think I suggest you, this is a specific problem. I suggest you looking up on the internet. And then just somebody might have already run into this issue and you would get an answer. I cannot quickly answer that problem. Which machine learning algorithm are suitable for voice related areas? This is a wider question. Probably when we go there to machine learning specific stuff, mainly voice recognition is handled by using deep learning based algorithms. So we will see maybe one algorithm from deep learning. We might see a couple of algorithms, and then you will get your mind set up on the best algorithm that you think of for your purpose. Which Python machine learning library or framework are we going to use in this course? We will use scikit-learn, which is the most popular machine learning algorithm, and you know, other algorithms can also be used depending upon the type of other frameworks or ML library frameworks can be used depending upon the type of algorithm that we are going to deal. But just you will get to know when we start using them. Would you say something on security of cloud-based coding? Yes, I already said it is secured by using your own account and password. And which machine learning algorithm are suitable for time series data? There are multiple, and depending upon your problem area, probably we will see one time series example. And what about Kaggle? Kaggle is a platform where people post their for competition purpose, and companies use Kaggle for you know, just putting some problems get solved by in a kind of crowdsourcing setup. Crowdsourcing setup means if you are a very good data scientist, and then you can look at some problems that get published on Kaggle, and you can address. And Kaggle also I believe provides server cloud-hosted servers for this, but I haven't tried, so I cannot say anything. Okay, I think I'm through with your questions, and now let me share again. So we are going to start the actual Let me know. I think. Okay. Okay. Okay, which environment is better for machine learning? It depends. Obviously, your local environment is not the best for your local environment is not the best for machine learning, because machine learning most of the time requires a very uh, performing servers. In most cases, we don't buy servers for personal use. So our personal laptops or personal desktops are not meant for machine learning, but you can use them for learning, um, executing some code in learning. Now, I am going and how is a project which has a reward will be done? Is it group work or individual? Yes, this is something that I have been thinking. Let me discuss this with the respective university coordinators, because just individual, as I see now, there are like just more than 150 individuals attending this course or this training, and probably just it could be an overkill for me to deal with that many individual submissions. So I might need the university coordinators to help me in the process of evaluating the project. So we might be making it a group project. A group project. So that's a very good question, by the way, just a good reminder. Okay, so I am going to share a code. Is there a question? Okay, somebody will raised their hand, but low complete. Okay, so I think we have this. We have talked so much about just some theoretical stuff. Now it is time to start, you know, trying the things that we should. I hate these. Okay, am I back? Just 1%. Can you hear me? Oh, perfect. Okay, good. You can hear me. Yes, good. Okay, so you see this code. I think enough. I got answer. Yes, thank you. Um, I think it looks like there is a time gap, and everybody says yes, and just the instant messages come one after the other. Thank you. Thank you for your confirmation. And now, before I go deeper into this presentation, um, one thing that I want to tell you is, if you remember, like just again in the same email that I shared, in this same email, just go back and check. In this same email, I shared Python Data Science Handbook, Python Data Science Handbook. And this book is found on GitHub at this location. And I strongly advise you to take a closer look at some of the chapters, because and What is this? Okay. Some of the chapters here. Let me show you here. And this is, and so if you want to run code, this book has got chapters, like as I said last time. Let's go to the book. So this book has got these chapters, and of the chapters, like we will be touching some of the areas today. The introduction, read it for yourself. Introduction to NumPy. We will be touching some of the aspects of this chapter and some of the aspects of pandas and matplotlib. And then just the machine learning is going to be like just a focus area for a couple of weeks. But it's important for us to, start refreshing. If you have already learned Python, we have to refresh. But in Python, there are three important things that we should know. The first one is NumPy. NumPy is a Python package for numerical calculations, mathematical operations, and things like that. And Pandas is also a framework, a package that enables us to manipulate data within it. And matplotlib is another package for exploring data visually, like for visually observe the data. So these are the three chapters that are outlined in this book from chapter 2, from chapter 2 to chapter 4. The machine learning is going to be something that we will be splitting into a couple of weeks and then just going through example. But it is important for you to know the language that we will be using for this purpose. Now, how can you execute the code? And I will show you quickly. So each of the pages that you would see here are written in a Jupyter notebook, and you can download the book, the entire book locally, but each section is a Jupyter notebook in this book. How can you get the code? Sorry, I have to go back. Let me duplicate these and close some of the things that I don't need here because they are making my window busy. Okay. Yes. Okay, Codespace. And here. Now, so this is a book. And if we go back, this is the book on GitHub. And if you want to download the book locally, you click here. You click here, like just now I am on GitHub. You have the link. The link that takes you to GitHub is the second link. This second link takes you to GitHub, where you can download the book, and then just here in code, you click here and you download the zip folder and unzip it on your local environment, and you can execute this code from Jupyter Notebook or from the Visual Studio Code, whatever integrated development environment. For me, I have Visual Studio Code. I have a Visual Studio Code. So this is the base code that I will be using, and the code. So as you can see, the folder structure here. So the folder structure is like here, right? Notebooks, V1, V2, tools. I think somebody said, can you maximize? If you are using your cell phone to see this, probably just you may have difficulty to see because I'm splitting. Yeah, unfortunately, it's not rendering properly because I minimized it so much. So let me maximize. Let me minimize it. Yes, now the code is visible. So as you can see here, notebooks here, and I don't think it's easy to maximize this code. Okay, let's see. Plus. Plus. Yeah, so I can't. I can't maximize this. Oh, I think it was maximized. Okay, yeah. So notebooks. So this is this, like just the from GitHub. I downloaded it and I have the code on my local environment. In any case, so the way you download is you have two options. If you know how to clone a repository, and then this actually requires well, either way an internet connection to continuous internet connection until you are done, either to clone or to download. Then just you download the code. Now, going to deeper into the code. So here I downloaded it and just I put it locally. And as I said earlier, in the notebooks V1, you can see like 0, 1, this like just everything that starts with 0, 1 is the first chapter. Everything that starts with 0, 2 is the second chapter, and it goes on. 0, 3, the third chapter, and 0, 4, the fourth chapter, up until 0, 4. And I say just you taking the time to read these chapters. And then just if you are really interested to learn machine learning, this book has got everything that you need to learn about Python, especially chapter 2, 3, and 4. And then just once you understand these, then just things get so easy for you, right? So and how can we execute? I am going to like we can use introduction to Numpy here, the first one of the notebooks, and then just in this notebook, the notebook exactly the way it is written to for the book. You have the introductory details, and then just in every position you would get this code. And as you can see, like this play button is to get the code running. And if I click play, and then the code starts running, and then it's going to run. And this means what is the Numpy? I have a Numpy package installed on my local machine, and it's version 1.20.3, 1.20.3. So this is a version of Numpy. And if you want to use Numpy, you have to import Numpy into your execution session, to this session. Just to do that, you have to set up cloud. You have to set up an environment where you can utilize. You have to set up just a local environment where you can utilize Python on that, and then just your local environment is going to be the environment where you will be installing all the packages. In Python, manage environments by folders. You can have multiple Python environments on a single machine, because you the same way as you can have multiple folders. And once you set up an environment, a Python virtual environment in a folder, everything that you installed on that virtual environment will go into that particular folder. And if you decide not to use that folder, then just you can get rid of that. You can deactivate, and then just here is the terminal where you can see you can see or get interact. You can interact with the environment. And now my environment is activated, and so just I was recently doing Conda activate ChatGPT, and then just ChatGPT is activated. So this is the name of the environment. But the Python kernel is loaded from the base. My base environment is at this folder, as you can see, this folder, and the ChatGPT environment is activated here. So okay, no, just the ChatGPT environment is activated in a ChatGPT specific folder, and then just currently we are looking at this environment. This is my code repository path, and it's Python data science handbook, and then it's a kind of duplicate, but this is the folder structure looks duplicate. You can choose your own folder structure for your purpose. But now, okay, so now so just before getting into Numpy, so this is how you would be executing, and then every single detail of these notebooks have got interesting knowledge, interesting details. And trust me, if you execute all of them, if you read through all of them, chapter 2, chapter 3, chapter 4, you are well ready for data science. Take your time and read through these 3 chapters, chapter 2, chapter 3, and chapter 4. Okay. Today I will do a quick walkthrough of this summarized version. As you know, just teaching is not just providing everything, but just providing a summary of things and where you can find to explore further. So you can explore further by going through this environment and set up your Python environment locally. Okay, set up your Python environment locally. If you have an internet connection, you can also set it up on the Codespace. That's another option that you can have on a Codespace or Google Colab. By the way, it automatically gives you that opportunity to. If you want to use Google Colab, let me show you how you can use Google Colab from here. I'm opening one notebook. So this is a code location, and let's say I was on introduction to Numpy, and it's open here. Okay, so the code is open. The Jupyter notebook. This is a Jupyter notebook. By the way, the Jupyter notebook's extension is IPyNB. Python notebook. This is the extension of a Jupyter notebook. And then just this button takes you to a a Google Colab. If I click this, opening Colab, and then just it takes you to Colab. Now Google Colab is getting opened, and there you go. So your code is ready, and then just you can connect to the Google Collaborator service. I mean, just machine or VM, and just is connecting, and I will show you how it runs. Earlier, we had 1.2, 21.2 on maybe like the author's environment. But for me, the version was 1.20.3, right? So just it depends on where you are running this. But this is not the latest, but this seems to be the latest. But let's see what is there in the Google Colab environment. In the Google Colab environment, it is 1.22. Again, just the most latest one. So it's a kind of a little different from the author's environment. In any case, so you can utilize the Google Colab by simply just going to clicking the Google Colab button on the notebook. So this button on the notebook takes you or opens your Jupyter Notebook on a Google Collaborator. But the issue is it doesn't give you. You have to click open on each of the files, and every time you want to open one notebook, you have to click this button as many times as you want you want files. So the local environment you can download, and everything is available for you. So just go through this, and you would enjoy learning. And I really loved the book, especially like just for one refresher, and even like just for some of you who might be teaching Python, you can use the entire book to teach Python for your students. Or if you're learning Python for the first time, I think just this book has done a very good job of explaining things. Now, okay, so introduction to NumPy, Pandas, and MATLAB. This is a summary, a short version of the 3 chapters: NumPy, Panda, Matplotlib, like chapter 2, chapter 3, and chapter 4 of the Python data science handbook. So we can go through each together. I know we don't have much time, but let's start, and then just I'm going to close the terminal here so that we can have enough room. Now, so the data analytics, data analytics, as we discussed last time, is a process of inspection, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision making. Now, the steps of data analytics, data manipulation, and data visualization involve, first, transforming the raw data into desired format, and second, cleaning the transformed data. Step 1 and step 2 are also as pre-processing of data. So the transformation, data cleaning are combined together as a pre-processing and pre-processing of data. Then the third step is preparing a model. This model could be a statistical model, or it could be a machine learning model. A statistical model is usually for estimation, but a machine learning model is for inference, for prediction, and forecasting. So depending upon your ultimate objective, you could transform data into your desired format. You clean the transformed data, and then just you train either a statistical or a machine learning model. And then just you analyze the trends and make a decision. So for this purpose, the 3 packages that we will most frequently use are NumPy, Pandas, and Matplotlib. So NumPy is the most popular package for scientific computing because it supports multi-dimensional array or matrices, and it has got methods for processing arrays, and it enables you to do element by element operations. And there are mathematical operations like logical, Fourier transform, shape manipulation, linear algebra, and random number generation. So these are there in Numpy. There are methods that are written for you. You don't have to, write everything from scratch. So just things are done, pre-cooked for you. And more importantly, it is the very fast package for numerical computations, especially matrix manipulation. Like if we simply use Python's just matrix manipulation, it would take minutes, while Numpy can do it in seconds. So this is how Numpy, how important Numpy is. Now Numpy gets installed on your environment by using Numpy. Like, just if you don't have Numpy or in your environment, you can do pip install Numpy. So if you use this, then just it will install. If you don't have Numpy, but we checked that Numpy is already available because we ran we ran like just a version check for Numpy, right? So this was like just a thing. We imported Numpy, and then just we basically ran this. Like maybe the first step is checking it. You try to import it, and then just you try to check the version. By the way, these are two double digits, two double dashes, right? Version and this double dash. This is available for any Python package. So you can use pandas as PD, and then PD. So, okay, this was wrong. Pandas, PD, and PD version. It will give you the version of pandas. Just the same for all. Numpy, and usually just imported as NP and NP version, then just you got this version. My local environment has got 1.20. Now, if this fails, if this gives you error, then just you'd have to use these to install pandas on your local environment if you are using local environment. Otherwise, if you are using cloud hosted virtual machines, most of the time they will have this because it's very popular package. Now, ND array means n-dimensional array, NumPy array. So the ND array is a multi-dimensional array object consisting of two parts: the actual data and some metadata which describes the stored data. They are indexed just like a sequence in a Python starting from 0. Like in Python, the index starts usually like just in programming language. Indexing is an important concept. Indexing means how do you identify items in that programming language? For example, in array, in a list, what is the beginning index? Some programming languages use 1 as a beginning index. For C#, for Python, for R, the starting index is 0. So each element in an n-dimensional array is an object of the data type object called D type. And an item extracted from ND array or n-dimensional array is represented by a Python object of an array scalar type. So let's see So here it is. We imported, so just we have to execute. If we don't execute this line, if we don't execute this line, it will fail whenever we use NP. So I am executing this, run, and then just it is done in 0.1 second. And now I am going to use NP, the Numpy package. From Numpy package, I'm using one method called array. So this enables us to create arrays of any dimension, n dimension. And now this is an array of one dimension, a one-dimensional array. We are creating a one-dimensional array. So this one-dimensional array, we are creating it, and then just once we create, we are printing it. Let's see. Let's create, and it's running. It's done. 1, 2, 3 is the array. As you can see, when arrays get printed, they don't have the comma separation. Like just it shows you like this, just with a space when you print them. Now this was one-dimensional array, because one array. Now this is a two-dimensional array between these two, right? A two-dimensional. The one dimension is horizontal, and the other dimension is vertical. 1, 2, 3, 4, like just the horizontal and then vertical. So, and if we print this, you will see. So this is how the dimension comes: 1, 2, and 3, 4. So horizontally we have 2 elements, vertically we have 2 elements, a 2 by 2 array. Just to see that, there is a special method called shape. So B is the array, and shape gives you the dimension of the array. So B gives you that it's a 2 by 2 array. B means this array that we created. Array of 2 rows and 2 columns. The 2 by 2, 2 rows. This is, and 2 columns. And we can also wrap a list in an array. List in Python is created just like this. Just a sharp cornered list of numbers, and you can have a list of multiple values. Like let's run this one, and then you have 1, 2, 3, 4, 5. And can we have like just A, B, and let's see. Right? Yes, we can have. The moment we added A and B here, everything got converted to a string character. You see, 1, 2, 3, 4, 5 were numbers. Now they became strings because we added a string. Or if I add another 1.2, and you will see, instead of just the numbers, I change it, and then just everything will become 1.2, 1.0. Just this is how Python represents when it prints 1.0, 2.0, 3.0. Now they got converted into a decimal, a float value. So just to keep the original example, 1 through 5, now they got printed clearly, just the way they are. If the types are exactly identical, Python doesn't upscale the type. So now, creating an array of numbers of a specified range. So from 100 to from 10 to 100. Then just look what happens. Array of numbers from 10 up to and excluding 100. Usually, when in Python, the last number is not going to be included in a range. In a range, the number on the left, the number on the right is not going to be included. The number on the left or the beginning included, the ending is not going to be included. If we print this array, a range is how you can create Python generated sequentially generated numbers. And imagine, look at this, 10, 11, 12, all the way to 98 and 99. It ends at 99. It didn't include 100. Arrange is a method on NumPy to generate sequential numbers. And I can do this from 1 to 10 just to simply show. And here you go. There will be only 9 numbers from 1 through 9, excluding 10. So to keep the original example, here we have 10 to 100. Any other, we can also create a 5 by 5 array. You see, so the array is like this. Note so if I say 1 to 10, look what happens. It throws an exception or whatever, but this accepts zeros, accepts a shape. This is a shape. Just I can say 5 by 5. Let's first print this, a 5 by 5 array, and this is called matrix. From your mathematics class, you know this how matrix gets represented, n by n matrix or unequal sized matrix. It could be, instead of 5 by 5, 5 by 6, then just the number of elements in each array are 6. And how many rows we have? 5 rows and 6 columns. 5 rows, 6 columns. 5, 1, 2, 3, 4, 5 rows, but 6 columns. 1, 2, 3, 4, 5, 6. So this is how the array is presented. Now the zeros are important. Sometimes, like, just you can create such arrays as placeholders to expect numbers and calculations be placed here. And creating a linearly spaced vector with a spacing. We can have a vector from 0 to 20, and then just the starting is 0, the ending is 20, excluding 20, and the step is every 5. So 5 step. So the vector now linear space. So this is lean space means linear space. Remember, this is the first parameter is the start. The second parameter is the end. The third parameter is the window, or like the gap between the first and subsequent between the subsequent numbers from 0 to 20. So let's see what happens. You see, 0, 5, 10, 15, and then 20. 20 is included. Is stopping at 20. 20 is included, unlike like indexes. And creating arrays from existing data. Now this is an existing data X, and we wanted to create as array. So this is used for converting Python sequences into n-dimensional arrays. So just now we can print here. We can run this, and then just here we go. We have this list. This list as created as an array, and converting a linear array of 8 elements into a 2 by 2 by 2 3D array. By the way, if you have elements, any number of elements, you can, any number of series elements. For example, like just let me show you this first before printing these two. I am commenting them out, and then array 3, and just look at the value. So we have zeros, 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros. Now the 8 zeros are created, and what's going to happen? What are we doing here? I am uncommenting this, and So like the dimensional array is like reshape. We are reshaping the one-dimensional array into a three-dimensional array as 2 by 2 by 2. 2 times 2 is 4. 4 times 2 is 8, equal to the total number of elements that we have. And then just the three-dimensional array will be created as this. So this is a three-dimensional array. A three-dimensional 2 by 2 by 2, right? And we have 1, 2, 3, 4. But the way it is created is 2 arrays as one here. You see, like this is one. The deeper array, the deeper contains 2 elements here, and these 2 elements here, and these 2 elements are considered as 1, 1, and 1. To each of these 2 arrays contain 2 linear arrays. Okay, and each array contains 2 elements. So this is, you start from the deeper and then just go to the outer and then just go to the most outer. And we can also flatten the array. Now, just we divided this into an array, reshaped into an n-dimensional array. Now we wanted to go back to a flat array. Initially, we had ARR3. Let me create this back. Initially, we have this flat array, right? All zeros, right? In 8 zeros, because that's how we created it. But after converting into a three-dimensional array, then just we got this three-dimension array. The one dimension is here, the second dimension is here, and the third dimension is here, right? So now we wanted to go back from the three-dimensional array. Ravel means it will convert the dimensional arrays back to a single dimensional array. There you go. So R4 is raveled the three-dimensional array into a one-dimensional array, right? Now, indexing NumPy arrays is, let's see. As we said earlier, a range is a sequential number generator method between the start and the end, excluding the last element. Then just we have this, right? We have this, and then just from this, what does A5 give us? So A5 and R5 or RA5 has from 2 to the last element sequential values 20. This is R5. Okay, this is the same array. This RA5 has got elements starting from 2 all the way to 19, excluding 20, because the last index, as we said earlier, is excluded, especially in case of our range. Now, from these, what we're doing is get the seventh element. The seventh element. The seventh element means you start the index. Index starts from 0. In Python, we said this earlier, from 0, and then just 1, and then 2. So 6 means the seventh element. The seventh element. 0, 1, 2, 3, 4, 5, 6. 8 is index 6, but if we count 1, 2, 3, 4, 5, 6, 7, the seventh element is 8. So this is what this did. It took the 7th element of array 5. Array 5 is this one. Then it is printing the value that this variable holds. And just as you might have noticed, we have like commenting here in Python. The hash is commenting in Python programming language, whatever in Python code, and we can go from here. So I'm going to put this folder, this file into I'm going file into the folder that I shared last time. And where was it? Gmail. I shared in the drive in Google Drive here, and this is my drive and foundations of, and then lesson slides. For today, we don't have lesson slides, but new folder, notebooks, and I will put this folder into this notebook. Okay. I have to open this and I have to put it here. So you can find the notebook. It is shared. This is the same folder that I shared with you last time. You can find this notebook, run through it. This is a summary of the 3 chapters from the Python Data Science Handbook. The Numpy, the pandas, and the matplotlib are there. We will continue going through this because understanding these 3 libraries is very important for our data science process. Any question? I know I went over time. Yeah, thank you, Kabra, for answering some of the questions here. And it has a fallacy with the normal mathematics. 1 through 10 is not 1, 10. Well, yeah, I think just this, whoever writes the language makes the rule. And I'm new, please, can I get link of that drive? Thank you. Yeah, so I think just I have to stop the recording and I will share